So you can go back and just like the first lecture is posted. So if you wanted to go back, you can go to the recordings and review over. And if you do, just to let you know, on the bottom, when it's playing, you can increase the speed. I find that going to 1.5 or 2 works a lot better than listening to me in a slow motion. All right, and brakes, right? Yesterday when we were, or the other day when we were in, I kind of showed everybody the different types of brakes, and hopefully that will help for the lecture today. But aircraft brakes, keep in mind, they are there to slow down and stop the aircraft. And we can actually use them differentially to help steer the aircraft or control the aircraft on the ground. Now, the brakes are, the size of the brakes is determined primarily by the weight of the aircraft and how fast the aircraft lands, okay? So heavier, faster aircraft need bigger brakes. Small, light aircraft that do not fly very fast or come into landing very fast do not need very much braking power, okay? And in some cases, some aircraft originally had no brakes at all, just because, well, come in, the rolling resistance was great enough that eventually you would stop, okay? So in brakes, we have single disc brakes, okay? And we also have multiple disc brakes, but right now we're just talking about single disc brakes. What that means is that there is a single disc, okay? So single disc. Now, in single disc brakes, there are two types. There's what's called a fixed disc and a floating disc, okay? A fixed disc is what we seen yesterday, in that the disc was rigidly bolted to the rim and is turned by the rim. But the fixed disc only can rotate, but it can't move in and out, okay? A floating disc is one that is rotated by the wheel through what we call disc drive slots, but it is not bolted to the rim. Thus, it's allowed to float or move in and out. Now, the main thing that we got to know here then is, if we have a fixed disc, then we have to have what's called a floating caliper, okay? Because for our brakes, something has to move, okay? And with a fixed disc, the disc can't move in and out, so the caliper has to move so that both sides of the disc are going to be grabbed by the pistons, okay? Whereas a floating disc, since it moves, it can use a fixed disc. And this is what I would, sorry, I can't believe I just did that. As you know, I meant to say a fixed caliper. Yeah, and the fixed caliper is rigidly attached to the landing gear itself. And then we have the piston that comes out, and when the piston pushing the brake pad against the floating disc moves the floating disc to the back plate or the back pad, okay? This is what I tried to show you yesterday and such, as far as the brakes go and how they move, so that you could understand it without me trying to describe it crazily today. So does anybody have a question as far as that goes? Keep in mind, we have single disc brakes. With a single disc, we have a fixed and a floating disc. A fixed disc has to be associated with a floating caliper, and a floating disc uses a fixed caliper. We're okay with that?
Yes, it makes sense.
All right. All right. Now, what ends up happening? Well, as the aircraft gets faster, gets heavier, we need more braking power. And so generally what they first do is they add the number of brake pads or pistons on the caliper. Eventually we go all the way around the, the wheel. And so then there's no more room to add more pistons, thus brake pads. And so the only thing that we can do is increase the number of discs. This is what's known as a multiple disc brake system. In a multiple disc brake systems, we have two types of discs. We have what's known as stators and rotors, okay? The stators are stationary, meaning that they do not rotate. So stators but they float. What I mean by they float is that the stators can move laterally, in and out, but they do not rotate with the wheel. Rotors, on the other hand, rotors rotate, okay, and float. And the rotors are rotated by the rim, generally by the disc drive slots. The stators don't rotate and are prevented from rotating by what is known as a torque tube. And we'll be seeing this, okay? So I'm going to continue on. All right, so what do we see here? This is a single disc brake, and it happens to be a floating disc. How do I know it's a floating disc? Well, one is we don't see any type of bolt holes or a hat section that we could bolt it to the rim. But we do see the little cutouts on the outside diameter of the disc. These are what's known as the disc drive slots, okay? And this is where it meets the rim, and as the rim turns, the disc turns, okay? But they can slide in and out. Also, we notice that the caliper has bolt holes, right, which is rigidly attached to the landing gear. So that's a fixed caliper with a floating disc. Here we have what's known as a multi-disc brake system. In a multi-disc system, and it's kind of a tough picture to see, but we can see that we have pistons all the way around, right? And then those pistons push against the pressure plate, which pushes against the rotor, then another stator, rotor, stator, all the way to the back plate, which is non-movable, okay? And it acts basically as a big clutch. Pistons push out and push all the discs together. Right here, we have a single disc once again. And this is the kind that we were working on yesterday when we removed and replaced the tire, in that the disc is bolted to the rim and cannot move in and out, but rotates. And so we refer to that as a fixed disc. Remember, if we have a fixed disc, the caliper is floating. And so we seen yesterday that there's two slide pins, one upper, one lower, that slides in the holding mechanism so that it can slide in and out. This also has a single piston. Now, as I said, some of them will have two pistons And then eventually we could fill up the whole circumference with pistons and pads to create more braking power. But when we do that and we need more, that's when we go to the multiple disc system. Here again, we have a floating disc system. In this floating disc, yes, the notches have been replaced with like a sawtooth design. So the rim actually has the sawtooth design also, where this is integrated into the rim. We can see where the fixed caliper is bolted to the landing gear. This one actually has 3 pistons, okay? I'm just going to make a quick mention that these little centerpieces we'll be talking about, these are parts of the what's known as the automatic adjusters, okay? And kind of the, besides automatically adjusting the brakes for clearance or adjusting for wear, the little centerpiece we can actually use to measure or to indicate how much brake pad wear there is, so that we can identify when the brake pads are below minimum and need to be replaced. Some of these pictures are really, really bad. Okay, so there ain't much that I can do about that. So I'm just going to keep on going. All right. I mentioned the automatic adjuster. Okay. And sorry to say, but this is the picture that they give us. Okay. Now, here's, I'm going to go through what's the purpose of the automatic adjuster. Okay. Well, the automatic adjuster is used to reposition the piston to compensate for brake pad wear. Okay. If we think about it, if the pads are brand new, the piston would be way back here. Okay. And when you apply the brakes, when the pilot applies the brakes, let's say that we only want the pad to travel 1/4 of an inch and it hits the disc. So really, we just need the piston to move 1/4 of an inch for the pads to grab a hold of the disc. Well, what then happens? Let's say, and I'm exaggerating here, but let's say 1/4 inch of pad is now worn off. If the piston always returned back to its initial spot, way back here, then the next time when the pilot applies the brake, not only do they have to move it 1/4 inch, but also the extra 1/4 inch that the pads have worn. So now the piston has to move 1/2 inch before the pads make contact with the disc. Can we see that as the pads wear, the piston would have to move further and further? Thus, the pilot, when they apply the brakes, instead of just moving their, the toe brake very small amount, they have to move it continuously further and further down. Okay. Well, to prevent this from happening, many brake systems incorporate what's called an automatic adjuster. I'm going to kind of go through this, but then I'm going to open up something else and share with you something else so that maybe you can better understand. But the parts of the automatic adjuster, we have this pin. Okay. Now, this pin rides through what's called a grip collar. The grip collar only allows the pin to go to the right. Okay, so the pin can only move in. Okay, it can't move out. Now, right now, this is showing a condition in which the pilot has applied some pressure to the brake. Okay, so the piston has collapsed the spring retainer, the return spring, where then the spring retainer is making contact with the grip pin. Now, we can see that there's a small gap between the head of the piston and the pin. When the pilot was to release the brakes, the piston would only go back that small distance here and stop at the pin. This is what compensates for the wearing of the pad. Now, for me, I know how it works, and I'm looking at it going, what the hell? So I am going to stop sharing this, and I'm going to open something else, all right? Okay, everybody see my total screen?
Yes.
Okay. Okay, this goes pretty quick, but I'll do it more than once. Okay, when I hit the play button, what you're going to see, and I made this animation a really, really long time ago. I was just playing around with it. I was like, oh, that's cool. I can't go back and adjust anything. So what we're going to see is the automatic adjuster and then the brakes being applied. All right, so it's quick, but this is kind of the picture that they show. But did you kind of see the yellow and the black come out and hit the pin?
Yeah.
Right? Okay. Now, when I hit the continue button, it's going to indicate like the pads are wearing. So the yellow piston is going to move to the right. That's going to drag the adjusting pin to the right. But then when the pedal is released, the piston is going to move back and hit the pin. Ready?
Uh-huh.
Moves it and then returns back. This is the standard when the brakes are released. This is what it normally looks like. Okay. So when I hit play again, it's going to move this to the right very, very quickly. Sorry to say. The spring retainer is going to make contact with the pin to drag it to the right. So there we go. And then the pads wear, and then we release. Everybody kind of see that?
Yeah.
Does that help anybody to understand it?
Yeah, I think so.
Okay, good. Yeah, I worked hard on that long time ago. Well, no, my idea back, I'm sorry to say, it was a long time ago, was to make an electronic, textbook for us. And so that, you could actually see things in motion and do stuff. Anyways, instead of just a stagnant picture. Anyways, can you see how far the pin is?
Yeah.
And see that as the brake pads wear, the pin's going to get shorter and shorter. And
Yeah.
this is why, like if I hit that play, see how far it's sticking out right now? Okay. And then when the pads wear, it's not sticking out as far. So for this type of system, when we're checking the brakes, we measure the distance that the pin is coming out. And if it's too short, we know it's time to replace the pads.
Okay.
All right.
Cool.
See, I had other ones too. I'll show you this one.
See.
Okay. This is like a starter circuit, right? For like power plant 2. Oh, we're going through starting and ignition systems. So it's like, okay, here's the battery solenoid, here's the starter solenoid. But what you can do, hey, when you turn on the battery switch, current goes through the solenoid, closes it, and now we have power to the bus bar. If we turn on the starter, current goes through there, and now the starter's operational. If we turn that off, hey, that's turned off. If we turn that off, hey, no more current. If we turn that on, and we turn that on. But if I turn off the master, it turns everything off. Ooh.
That's cool.
And from there, I was going to add like, okay, this is how the system normally operates and play with it. And then it was like, would be hit a button and like install a fault, and then it would create a fault in the circuit somewhere, and then you would have to like turn this on, turn this on. Oh, okay, look, I'm still, like, the solenoid's not closing. Okay, what's the problem? Solenoid's not working. Okay, what do you want to test? Oh, I want to test wire A. I want to test the switch. I want, you know. I digress. Okay.
Cool.
Okay, so hopefully that's a better understanding of the automatic adjuster. Once again, the automatic adjuster is there to compensate for the wearing of the pads. The automatic adjuster, how far the pin sticks out from the caliper, can be used to indicate brake wear. Sorry, give me a second. Okay. Okay. Here, a person removing a tire from a multiple disc brake. You can see the little tangs coming out. Those would be the rotors and that. As I mentioned the one day in class, when removing the tires, as we removed the tires yesterday, we actually had to disconnect the brakes. With a multiple disc brake system, generally what we will do is we'll actually apply the parking brake, and that way the disc stack stays in proper position, and then we can just pull the tire out, but it facilitates putting the tire back on. Okay, here they're just showing the caliper itself. Okay, and you can see kind of the transfer holes, like hydraulic fluid comes in here and then feeds it all through each piston, or the piston cavity. Here's another automatic adjuster, nothing big, but this one, sorry to say, you cannot use because it does not stick out. So generally they will have another not automatic adjuster, but a wear indicator pin. Okay. Here we have this one. If you notice, this is the stator of a multiple disc brake system. And as I said, the multiple disc brake, the stator can float, but it can't rotate. What holds it from rotating is this device here, which is called the torque tube. Okay, and you can see the protrusions coming off of the torque tube that fit into the little notches of the stator. Okay, now many times I ask this question: if you see in the stator, notice that there's a slot with a hole. You know, there's a cut in it with a hole. Any idea what that is for? If anybody wants to speak up.
Cooling, maybe?
Okay. It's a good answer, but it's not the full answer. Okay.
To prevent the stator from spinning, right?
No, not spinning. It's to prevent warping of the disc, because the brake discs are going to get extremely hot. When metal gets hot, they try to expand. If this was one solid piece, they would try to grow and expand, and they would actually warp. And so those slots are designed for the thermal expansion of that disc. Okay. I'm going to go offline a little bit, but like in automobiles, right? You will have plain discs, right? And usually plain discs come from, you know, just a flat metal disc, kind of what we seen yesterday. Then there's discs that are actually, they're called drilled, and they'll have holes drilled all through them. Some even will have what's called slots. Have you ever heard of this? A slotted disc, or a
Yeah, I have some in my car.
What's that?
I have some in my car.
Okay. Any idea what the holes are for?
I always thought it was all for cooling.
Okay.
Yeah.
And I'm not saying it doesn't aid in cooling, but it's, the real purpose is not for cooling per se. Because if
But
you
for lightning?
notice, most automobile discs are pretty damn thick, right?
Yeah.
And then if you look on the outside of it, there's actually veins that when it spins, it actually is picking up the air and helping to cool that big disc. So it has like a built-in fan, if you will. What these holes are for, and even the slots, is for dust, especially the slots are for dust. But because if you have a flat disc and a pad is rubbing right up against it, you're going to create dust, and you'll get dust trapped in between the disc and the pad, which will cause squealing and loss of friction. But
Oh,
one other reason is this, and I'll try to do it bigger. Okay. When the pad goes in against the disc, it's going to trap air in between because you got two perfectly flat surfaces. Now, when you heat up air and you've trapped this air and you heat it up, guess what it wants to do? It wants to expand. So it reduces the friction between the pad and the disc. By having the slots and the drilled holes, the air now has a place to compress inside the disc. So more contact between the pad and the disc. I don't know if anybody's driven their vehicle really, really hard before. And when I say really hard, meaning operated the brakes really, really hard for a while, but we'll get what's called a fading brake. The pedal feels hard, but you know that you're not getting the proper stopping power. That, originally when you first start driving, man, you hit the brakes and you're stopping. You hit the brakes enough and you get them really hot, you hit the brakes and it's like, okay, my pedal's solid, but I'm not getting the friction. I'm not getting it to stop. That is known as a fading brake. Okay. And that's caused by entrapment of the air between the brake pad and the brake disc.
And it could be scary sometimes.
Yeah. But that's the whole thing with this, that's why the upgrade on more performance vehicles, then they go to slotted brakes or disc or drilled and slotted and such. Yeah. And also, like on motorcycles, you see it quite a bit. A lot of times that's also because of water, to be able to get rid of the water. All right. To continue on, we can also see that we have these little tangs coming out, and that's actually then the rotor. Okay. So here we have the rotor. Underneath is the stator with the torque tube. Again, we have the little cuts in them for expansion. Now, both of these, if you notice, that's plain steel, and the rotor, it's steel, but it has a sintered material on it, basically a friction material that has been applied to the steel ring. This was really, really common in the earlier type of multiple disc brakes. But what they found is that, wow, we removed the friction material, and now when we go to do the brakes, we have to replace all the stacks of discs, meaning the rotors and the stators, which get really, really expensive. So this is when they evolved to then, well, sorry, it's far up ahead, to having pads put onto the discs. That way the pads wear, and then during overhaul and that, the actual disc is saved majority of the time, or a lot of times the discs can be saved, and all we have to do is replace the pads. And generally, to be honest, the brakes on especially large commercial aircraft, there's repair stations that just specialize in overhauling of brakes. So a lot of airlines in that, they send out their brakes to be overhauled through a specialty shop, being a repair station that only really does brakes. Because it is time consuming and it's very expensive, as we talked. I mentioned that, brakes and the landing gear. Sorry to say, but majority of the time, they're just a lot of dead weight because, the airplane is designed to fly. So in the air, the landing gear is absolutely doing nothing. The brakes aren't doing anything except making us burn more fuel. So they came up and said, how can we reduce the weight of the brakes? Because they are heavy, okay? So they came up with carbon disc brakes. Now, when the carbon disc brakes first came out, I gotta say, they ran roughly twice as expensive as standard brakes. Whereas standard brakes might cost $35,000, these were $70,000 per, okay? But when they first came out, they claimed that these brakes will last twice as long, at least twice as long as standard brakes. And thus, paying twice as much, you get twice as long life. And they said, and because they're lighter, during that life or during the operation, you're going to save money on fuel. Well, people did, purchase them, they got them, and did they weigh less? Yes. The problem was, did they last twice as long? And the answer was no. Okay. They barely, if they lasted as long or maybe a little bit longer than standard brakes, but that was it. And a lot of the operators went back and said, we don't want the carbon brakes. We're paying a lot more money. The weights, the fuel savings because of them are not compensating us for the additional costs. So get rid of them. But they knew they had something. And so the engineers went back and they redeveloped the carbon matrix of what the material is made out of, or the formula, if you will. And so today, a lot of aircraft are now coming out with the carbon brakes. They can handle a lot more heat than the standard style brakes. They're lasting longer, they weigh less, but they cost a lot more than the initial. But the payoff is over the long run, you will save money.
Quick question, do aircraft use any type of like ABS system?
Yes, we refer to it as an anti-skid system. Okay. We will talk briefly about it, and I know it's kind of crazy to think that, well, Bob, we're in landing gear and brake systems. Why wouldn't we talk about the anti-skid system? Well, because that's actually taught in Airframe 2 under position and warning systems.
Okay, thanks.
Okay, so yeah, we'll briefly talk about it, but I think I mentioned this previously, and that is when I would teach Airframe 2, and I've already taught Airframe 1 to the people, and then it was like, oh God, I already went through it, the anti-skid system. Oh, I did this, I did that. Ooh, we don't have nothing to go through. So I don't want to take anything away from Tom. Okay. But we will mention it and what works. All right. Continuing on. All right. So we did the multiple disc brakes. We did that. All right. So in the early days, really the first brakes on an aircraft was basically taken from a horse and carriage, where then here's the wheel and then a block of wood kind of shaped as the tire. And then a person in the carriage had a handle. You pull on the handle, the wood block would hit the tire and slow it down. And that was the original brakes. From there, we eventually increased. Okay, and this was, by the way, known as a mechanical brake system. And the bar, ready for this? The bar that the person pulled on is called a Johnson bar. Anybody see the joke there? Okay, I'm going to call on you, Silva.
I
Okay.
missed I missed it.
Oh, okay. For mechanical brakes, right, there was a bar that the person had to pull on to operate the brakes. The bar is called a Johnson bar.
Johnson bar. Okay.
Okay, so the
I got it.
question is, what did the pilot have to pull on to
His-
stop the aircraft?
His Johnson.
Very good.
I love it.
Hey, I'm not lying. It's called the Johnson bar.
I see.
No, why is it called Johnson bar? I really don't know.
Maybe the guy who made its name was Johnson.
Probably. All right. So from the mechanical brakes, right, with the Johnson bar and cables and such and direct putting pressure onto the wheels, they went to basically what's called a drum brake. And I know a lot of people are unfamiliar with drum brakes, but the drum brakes used in aviation was kind of special. It's known as an expander tube, okay? So what they're showing here is the drum, and the drum would actually come down like so. And, you know, the wheel, it's inside the wheel and stuff like that, okay? Well, here is the expander tube. Think of an inner tube, just like we seen yesterday, or a bicycle inner tube. And on this inner tube is a brake pad or the brake lining. When you were to push on the brake pedal, hydraulic fluid would come in and expand the tube to push the lining up against the wear surface of the brake drum. Okay. When you release the brake pedal, and by the way, there's the brake pedal, this actually worked more like a giant syringe. Okay. So here you have a piston and a pedal. And so if you push fluid that way, it blew up the tube, and the pad then put pressure against the drum. When you release the pedal, the plunger would move back, drawing the fluid out of the tube and back into the cylinder. And thus the tube would contract and release the brakes. This, by the way, is known as a closed hydraulic system. Okay. Now, the problem with a closed hydraulic system is that it's not vented to the atmosphere. Okay. And so a problem developed. Remember how we said that fluids, we cannot compress, nor can we, we can't compress hydraulic fluid, okay? We can push on it, but we can't make it smaller, meaning compress it, okay? But hydraulic fluid will want to expand and contract by temperature. Well, this is what would happen then. A pilot would apply the brakes, push the piston in, fluid goes, expands the expander tube, the brakes start to drag. Now, what's supposed to happen? When we release the brakes, the fluid is drawn back into the master cylinder and thus releases the brakes. But as we apply the pressure and the brakes start working, what do we produce? We produce large amounts of heat. And when you release it, The problem is that the hydraulic fluid, the brake fluid got hot, so it would expand. Because it expanded, it would not totally release the brake. So the brakes are still dragging. As the brakes drag, it produces more heat. As the brakes produce more heat, we have thermal expansion of the fluid, and it even tightens up even more, thus creating more heat. And eventually the fluid could get so hot that it would expand enough that it would actually lock up the brakes. And the only thing that the pilot could do is wait until it cooled down, the brake fluid cooled down, to be able to move the aircraft. Are we good there?
Yeah. That
Um,
seems annoying though. If
yes.
you are
That's why we
breaking.
don't use it, but that was, that was our small little steps. We went from pulling on our Johnson to having a hydraulic, but a closed hydraulic system that then would make the brakes drag, and then we'd have to wait. Okay. When we get back from our short break, we now go into the more modern day from the 50s of the independent master cylinders.
Okay,
All right.
cool.
And so with that, Bob is on a break, and we will be back in about 10 minutes. We good?
Yep.
All right, so we are back. And we are now talking about the brake actuating systems, the independent master cylinders. Okay. The independent master cylinders, what that means is that we have a master cylinder for the left brake and a separate independent one for the right brake. This allows us to have differential braking. What that means is that the pilot can push on the right or the left brake independently of the other, so that they can control the aircraft better on the ground. If they need to turn the aircraft sharper to the right, yes, they can push on the right rudder pedal to move the nose wheel to the right, but they can also add brake on the right wheel and thus turn the aircraft sharper than if they just use the nose wheel steering. Okay. Now, it is a very simple system. We're going to look at what's inside the master cylinder. The master cylinder is now known as an open system. And the reason why it's known as an open system is because there's a reservoir of hydraulic fluid that is vented to the atmosphere through the fill plug that has a small hole drilled into it as a vent. Okay. Now, from the reservoir, we have a piston. Okay. And below is then the cylinder. Okay. When the piston goes down, this is what pushes fluid to the caliper, which then pushes the piston out to actuate the brakes. If the piston was just a piston there, it would be a closed system, very similar to the expander tube type. But a very important part of the piston system is what's called the compensator port. Okay, and I'm going to lift this up so we can see it a little bit better. Okay, so right here is the highlighted or expanded of this right here. So here we have the piston, okay, and the O-rings that seal it against the cylinder. But what we can't really see, or it's very hard to, there's a washer here with O-rings, okay, and this piston actually has an area where the fluid here, I got to hit draw. Fluid here is able to go through and come out and go to the reservoir. And this fluid can flow either way. So when the brake is released, okay, the compensator port, this part here, is open, okay? When we push this down, the compensator port then is closed, trapping the fluid in the cylinder to be pressurized to the caliper. Okay. And so there's this nut here, a spring that determines this gap. Okay. And this is what's known as the compensator port. Now, why do we have the compensator port? Well, one is so that when the brake is released, the fluid going to the caliper can't be pressurized. If we have thermal expansion of the fluid would go up into the reservoir and could expand. And the air that's in the reservoir would leave through the vent. Okay. If, for example, if we were to lose any fluid, let's say through a small leak, through the bleed valve or past the O-ring or a loose fitting, right? This system, when we release it, okay, fluid here in the reservoir could replace any lost fluid. Does that kind of make sense? Now, a lot of these systems may or may not have the automatic adjusters, but it doesn't really matter. When the piston first, as we apply the brakes, when we release the brakes, the piston moves up, which then pulls back on the piston to release the brakes. Then as this goes up further, we will see it tomorrow, or sorry, Monday. There's a sleeve in here that makes contact with the piston. The sleeve here makes contact with the piston, which opens the compensator port. So the compensator port allows the venting or the expansion of the fluid to go into the reservoir. The reservoir is vented for thermal expansion and also closes, the compensator port closes to trap the fluid to put pressure to the caliper to activate the brakes. All right. Good.
Is that the same as the master cylinder that's behind my clutch in my car?
No,
Okay.
no. It's, you still have a master cylinder there. You have a master cylinder for your brake and
Okay.
such. They work relatively the same way, yes.
What do they make the housing out of? Is it plastic?
Ours are metal,
Okay, that's good.
Yeah.
Okay, because the one in my car is plastic.
plastic, yeah,
Yeah, it's cracked before and leaked everywhere. I've had a
right. And then you lose it and
Yeah, all the carpet gets destroyed, all the hydraulic fluid goes everywhere.
well, okay. Cars today, after, what was it, 1967, have what's known as a dual bowl master cylinder,
Okay.
okay? And so,
So is it one that controls both?
okay, so if you ever put brake fluid in your, well, actually nowadays, you have a separate brake fluid thing, but the master cylinder on older cars would have two bowls, but one cap. And when you open up the cap, you will see a forward bowl and a rear bowl. Now, depending upon the manufacturer, Ford's generally say this is forward. This bowl is smaller and operates the rear brakes. And this one here, the rear operated the front brakes. Okay. My 1965 Mustang had a single bowl master cylinder. Now, the single bowl then powered both the front and the rear brakes.
Okay, that makes sense.
Yeah.
Same time.
Except, why did they go from a single and then eventually made it mandatory to have dual bowl? Well,
Redundancy?
here's what happened to me
Okay.
and why they eventually came up with that rule. I was driving home from work one night at Publix, when I worked at Publix in high school, and I'm going down Hallandale Beach Boulevard, if you know where that is.
I know where that is.
I step on the brake to stop at a red light, and I had pressure. It started slowing down, and then the foot pedal went straight down to the floor, and I had no brakes at all.
Oh, no.
And by the way, my parking brake or emergency brake was not connected. So
Oh,
absolutely no brakes. I did not die that day. I survived, get into a wreck. Luckily, I was able to coast to a stop and everything. When I investigated, I found the right rear brake line rusted through and blew out
oh, no.
because I only had one master, one bowl that basically
Leaked everything out.
leaked everything out, and I had absolutely no brakes. If I had a dual bowl at that time, I would have lost the rear brakes, but I
Okay.
still would have had front brakes.
Okay.
Okay. And so nowadays it is standard that we have a dual bowl. By the way, just to let you know, I have switched my car over from complete drum brakes to I have 2 disc brakes in the front, and I put in a dual bowl master cylinder.
Nice.
Yeah. All right. So that's the independent master cylinders. Now, what we have to understand about the independent master cylinders is that the braking pressure applied to the brakes is dependent all upon how hard does the pilot push on the brakes? Okay. It's like having manual brake systems in a car. Most people don't have manual brakes anymore. They have what's known as a boosted brake system, where manifold pressure of your car or vacuum assists you in applying pressure so you don't have to push so hard. Okay. Well, in very small aircraft, light aircraft, pilots have enough pressure to apply the brakes to stop the aircraft. But as the aircraft becomes bigger, heavier, and they land faster, we need more braking pressure. And this can be or exceed what the pilot can actually apply efficiently. So we have what's known as a boosted brake system. In a boosted brake system, the pilot, remember it's the rudder pedal on the toe, is
Right.
connected to this lower shaft. When the pilot, now we have what's called, let me clear how I want to say this. An aircraft with a boosted brake system has to have a hydraulic system. Meaning an aircraft hydraulic system, an independent hydraulic system that is, pressurized by hydraulic pumps and stuff like that. So right here, we see that there's a hydraulic line that says system pressure inlet. So this could be, say, 1,500 PSI of hydraulic pressure. It could be 3,000 too. It depends upon the aircraft, but I'm just going to use 1,500 PSI. So we got 1,500 PSI of system pressure coming in. But when the brakes are not being actuated, we have this thing called a spool valve. The spool valve is in such a position that no system pressure can come in. Okay. Now, we have our compensator port. So when the brakes are released, the fluid, I'll just call it brake fluid, can be vented and through the small little hole in the spool valve and out to the return. So once again, the brake fluid is vented back to the reservoir so that pressure cannot build up due to thermal expansion that would cause the brakes to drag. I got to erase now. Now, when the pilot first puts on the brake, right, they pull this part down by pushing on the foot pedal. Remember how I said the foot pedal connected to there. So when we push that down, this rod comes down. That first closes the compensator port. So now we've trapped the brake fluid going to the caliper, and we can apply some pressure to the caliper. But if the pilot needs more braking power, they just push on their feet again, meaning on the toe brakes, and this activates what's called a toggle. This toggle pushes the spool valve down. When the spool valve comes down, that small little, like where this opening is, there's a little hole. This will align with the system pressure. So system pressure now can act upon the top of the piston to aid the pilot in applying pressure to the brakes. The top of the return to the reservoir has now been blocked off by the top of the spool valve. So now we have additional pressure going to the brake. And this is what's known as a boosted brake system. A boosted brake system uses system pressure to aid the pilot in applying pressure to the brakes. Now, for mechanics, let's say a pilot says, hey, I really can't stop. I'm trying to apply pressure, but, it's still not as good as it should be. Well, we can adjust the amount of system pressure to aid the pilot in applying pressure to the brakes, okay? And we do that by adjustment of the toggle, okay? So what we normally do is in the brake fluid line going to the caliper, there's usually a tee-off area, and we'll hook up a pressure gauge. Yeah, and then we'll tell someone to go in. Hydraulic system, meaning is pressurized, and say, okay, apply the brakes. And when we apply the brakes here, we will get a pressure reading. If we need to increase it, we then can adjust this toggle to increase how sooner that the spool valve will apply pressure. So then we'll get more pressure here. If the pilot, is complaining that, whoa, as soon as I hit the brakes, man, they lock up and stuff, then it's too high a pressure. And so we adjust it so that it's within specifications. Okay. Any questions on the boosted brake system?
Not for me.
Okay. All right. So we did the independent master cylinders, the boosted brake that uses system pressure to aid the pilot in applying pressure. And now we go to the power brake system. Okay. Most large aircraft, if not all large aircraft, and some even corporate jets and such, and even some smaller ones, have what's known as a power brake system. What differentiates a power brake system from a boosted brake is that the pilot in a power brake system applies no pressure to the brakes themselves. Okay. All they're doing is controlling a brake valve, which controls the hydraulic fluid that is being directed to the brake assemblies. Okay. So all you're doing is moving a valve to increase or decrease the system pressure going to the brake caliper. Now, I will say this, that yes, I want you to know all of these components and how they are laid out. It's not that tough, okay? But for example, I want to see something. Okay, they're using 1500. Okay. The book is talking about 1500 PSI, so we're going to use the 1500 PSI. Okay, so if we have system pressure of 1500 PSI, now remember the system pressure not only operates the brakes, but it operates the landing gear to go up and down. It operates the control surfaces. It could control the flaps. It can control a lot of different things. It's the hydraulic system, okay, of the aircraft. Well, the hydraulic system is going to come in and go through a check valve. The purpose of the check valve is so that if anything goes wrong with the system pressure, we're going to capture a specific amount so that we have emergency use of the brakes, okay? So that if the system, say the hydraulic pump fails, we're going to store hydraulic pressure or hydraulic fluid under pressure with the use of what's called a brake accumulator, okay? Now, I know this is a lot of hydraulics, and if you haven't had airframe too, you're going, Bob, I don't know what an accumulator is. Okay, so I'm going to describe what an accumulator is.
Okay.
In this accumulator, it's a sphere. It could be a piston, it doesn't matter. And there's this black line, right? That's the diaphragm. The blue is nitrogen. The top, the red, is the hydraulic fluid. So how an accumulator works is this. Now remember, we have a check valve. The 1500 PSI comes in and it pushes against the diaphragm to compress the nitrogen. So now when this pressure is 1500, when the nitrogen pressure gets to be 1500, no more fluid can flow in, okay? Now, The check valve prevents the diaphragm. Let's say system pressure goes to 0. Well, if we didn't have the check valve, the diaphragm would expand and push this fluid back out to the system. We don't want that to happen. We want to store that for the use of brakes. Okay. And so we now have hydraulic fluid under pressure, say 1500, disregarding if the system pressure or this hydraulic system is functional. Now, if the system's working, not a problem. We don't even notice it. But if the system fails, we still have enough to apply the brakes a few times. But every time we use it, some of the fluid flows down and is returned. And so the diaphragm would go like this, then go like this, and then go like this. So this could be 1500, this could be, 750. Okay, and then there's 0 pressure. So every time we use it, the nitrogen expands and pushes out more fluid. So we have the check valve, then the accumulator. Check valve is to prevent the accumulator sending fluid back to the hydraulic system. Now, goes to the accumulator, and then we go to what's called the power brake valves. The power brake valves is what the pilots are controlling with the toe brakes, okay? And that directs the fluid then to what's called the anti-skid control valves, okay? That is what, I think it was Silva or whatever, or was it Andres, said about an ABS, which is anti-lock braking system. We call it an anti-skid system. To an anti-skid control valve. What the anti-skid control valve does is this. The pilot says, I want braking, okay? On a large commercial airliner, the pilot cannot feel the brakes, meaning they can't feel that the wheel is skidding or doing it, and everything is happening so quickly in such a short time, they can't like release the brake and reapply the brake and do all this thing. Things are going way too quick. Okay. If anybody ever drove in snow and icing conditions.
Oh,
Okay.
yeah.
All right. Now, cars nowadays pretty much standard to have an anti-lock braking system or ABS. But back in the day that wasn't around, what did you do? Did you ever like slam on the brakes? Absolutely not. What you did was you pressed on the brake and then you kind of pulsate the brakes with your foot. You push down, you release, you push down and release, and that was to kind of slow you down without allowing the wheel to skid, because a skidding tire has very little friction, okay, and won't slow you down. Anyways, the anti-skid control valves, as far as in the system, if the pilot's saying, yes, I want full brakes, the valves are getting a signal from a control box. And the control box gets a signal from what's known as wheel speed sensors. The control box is a computer. What it does is it knows how fast the wheels should be decelerating, okay? So the wheel speed sensor says, okay, the wheel's turning at a certain speed and the control box is calculating the rate at which it's decelerating. When the pilot pushes on the brake, the anti-skid control valve now, through the control box, sends a signal to the anti-skid control valve and says, okay, we're going to allow this much pressure to be applied to the brakes. The excess fluid is then returned back to the system. So, for example, if the wheel speed sensor says, hey, the wheel is skidding, the control box says, okay, we need to release the pressure so the wheel starts to spin again. Unlike ABS, ABS mainly just releases all the pressure to the brake to get the wheel spinning again. Our system many times doesn't release all the pressure, but just enough to allow that wheel to regain its speed, and specifically back to the speed that it should have been at. It's a very, the control box is very elaborate, okay? But really, there's only 3 components to it. Anyways, so from the power brake valve, it goes to the anti-skid control valve to what's called the debooster. The debooster does 2 things. It reduces pressure, but increases volume. And I will be talking about the debooster later on. And then it goes to what's called a shuttle valve. If our normal braking system is working, hydraulic fluid then goes through the shuttle valve to the caliper. But let's say we had a failure of the brake system. Then the pilot has an emergency brake valve inside the cockpit on the instrument panel, near the glare shield usually, and has a valve. The bottle is filled up generally with nitrogen. There's an air oil transfer tube, so when the valve is open, nitrogen pushes on a piston that pushes hydraulic fluid to the shuttle valves. The shuttle valves closes off the regular brake system and pushes hydraulic fluid to the calipers to stop the aircraft. The emergency brake system, though, is pretty much, if you turn it on, you can increase the pressure to engage the brakes harder and harder, but you can't release the pressure, okay? So once the emergency brake valves are actuated, eventually, when the aircraft stops, the wheels will lock, and sorry to say, the only thing you can do is, yes, you got to shut off the valve here, and then you got to bleed off the system itself to be able to move the aircraft, and then go through the maintenance manual as far as resetting everything. Are we good there?
That seems like a lot of work, but yes, we are.
Okay. All right. So once again, I might ask you on a test question, for example, is the power brake valve before or after the anti-skid control valve? You know, so that's what I'm saying. Is the debooster before or after the power brake valve? You know, like where are they in line? Okay. Now, we're going to take a closer look now at the power brake control valve.
Ooh.
And we're going to start over here, okay? This is going to be our number 1. This is the power brake valve, and as it is, it's released, and the fluid from the brake, okay? So this is when the pilot has released the brake or has not applied the brake, you know, no brake pressure going to. So what do we have? Once again, we have this, what's called a spool valve, okay? Now, hydraulic pressure is trying to come in, but it's blocked off by the spool valve. The brake cylinder, or I'll just call it the brake fluid, has a passageway to return back to the hydraulic system reservoir, okay? So that passage is open. Now, when the pilot applies pressure, okay, so they're going to push onto the brake pedal, which pushes this way. Now, there is a spring connecting the foot pedal shaft to the spool, is a spring. So as we push over, we push the spool valve over, which now we can see the return is totally blocked. The spool valve has moved over enough so that system pressure can now go to the brake cylinder through the debooster and through the anti-skid control valve. So now, here's the interesting part. Ready? I know all of it's interesting, but here's the interesting part. The pilot pushes it off, and let's say they want medium braking, right? So they put medium pressure, it moves over. Well, as the brakes are applied, this pressure builds up and it acts on the spool valve, so it actually will move to the right. So now we are in this position. The brakes are being held. So what happens? The spool valve now gets pushed to the right because of the pressure buildup, closes off the system pressure. We've trapped now the brake fluid going to the caliper because the spool valve hasn't moved over far enough to be released. If the pilot needed more braking, they push harder on the pedal. The spool valve moves over to open up the system pressure to go to the brake cylinder. Once that pressure builds up to correspond with how hard the pilot is applying the brakes, the spool valve moves over to trap that fluid. If the pilot releases the pressure, right, the spool valve now keeps the system pressure blocked, but opens a passageway to return some of the pressure to the reservoir. And what this also does is gives a sense to the pilot, how hard are they applying the brakes? Because if you push lightly, the spool valve eventually pushes lightly on your foot. You push harder, the pressure builds up more, the spring gets compressed more, and you feel that spring compression on your toes. So you have an idea of how hard you are applying the brakes.
Cool.
Are we good there?
Yeah.
All right, we're going to keep on going. Now, as said, from the power brake valve, it goes through the anti-skid control valve. Now, the anti-skid control valve, sorry to say, is discussed more in detail with airframe 2. But all we need to know about it is if the control box senses, hey, a wheel is skidding, what does it do? It redirects the fluid that would go to what's called the debooster. It would redirect it back to the reservoir so that that wheel could start spinning again or prevent a skid. So from the anti-skid valve, then it goes to what's called a debooster. Okay. Just a minute. All right, sorry about that. All right. Here's the thing to understand. It does, if you notice, it says that we have 1500 PSI coming in, but we only have 300 PSI coming out. So that's why it's called a debooster, right? It lowers pressure. Okay. But if we remember from physics in general, if we do something like in mechanical advantage, if we decrease something, we're going to increase something. Or if we increase something, we're going to decrease something else. If we notice how this is working, for example, here's the piston, and it says that it's 2 square inches. Okay. We now have to look at the volume. Okay. When this moves down, and let's say this moves down 1 inch. Okay. When we go 1 times 2, we have a total of 2 cubic inches of fluid or movement downward. Okay. But this is acting now on a piston that's 10 square inches. So when this moves down 1 inch, it's actually pushing out 10 cubic inches of fluid. So we lower the pressure, but we're increasing the volume going to the caliper. Okay. Now, I'm going to try to show you this. Let's say we have 5 pistons. Each piston is 2 square inches. Okay. If we did not have a debooster and we wanted each piston to extend out 1 inch, we would have to push this down 5 inches to get the pistons out 1 inch. That's a huge amount of travel. And I know I'm using inches, and generally we don't want our pistons to come out 1 inch, but you get the idea. In this case, right, all we have to do is move the piston down 1 inch and the pistons would come out 1 inch. Why? Because we have 10 cubic of fluid so each one would get, 2, so that would be 5. So that would be 1 inch. Does that kind of make sense? Hello.
Yes, sir.
Okay. Thought I lost everybody. Okay. But what it does is it allows a quicker application and release of the brakes. Okay. Without the pilot having to move a whole bunch of fluid up top. Now, some people would say, but Bob, we went from 1,500 pounds per square inch to 300. We don't have enough force. Well, that's not a problem because the force applied is the same. And let me show you that. If we have 1,500 PSI acting on 2 square inches, right? We have a total of 3,000 pounds of force. Okay. Now we have 300 PSI. But remember, we got 2, 4, 6, 8, 10 cubic, 10 square inches of piston. So 10 times 2, right? 10 times 300, 10 times 300, sorry, equals 3,000 pounds of force. So the force being applied is the same, but we're able to allow the actuation of the brakes quicker.
Okay.
Are we good there?
Are we gonna have to do some formulas to figure this out on the test?
Oh, absolutely not.
Okay.
Okay, here's, well, oh, I don't like the FAA questions.
I know.
Okay, because you will see that the FAA question on this, I don't have my book handy. Where's my book? Where's my book? Oh, I'm not going to try to find it, but when you go through the FAA questions, the FAA question says like, what's the purpose of a debooster? And I believe they want to lower the pressure and to release the brakes more rapidly. Something like that.
Okay.
Okay. No, to me, it's totally wrong. The purpose of the debooster is so that the brakes can be actuated and released more rapidly.
Okay.
Oh, I don't. Let me see if I can find the question.
Okay.
And by the way, I hope you guys know that the brake section has a hell of a lot of questions. Oh, there it goes. Okay. A brake debooster valve is installed in a system where the high pressure of a hydraulic system 3000 used to operate brakes. that are used on aircraft having high landing speeds that are designed to work with lower pressure. Okay. Okay. I don't like that answer either, but that's what it is for that one. There's other, debooster valves are used in brake systems primarily, and they reduce the pressure and release the brakes rapidly. Personally, I like answer C, which is ensure rapid application and release the brakes. Yes, it reduces the pressure, but it reduces the pressure to increase the volume. Yeah, you see what I'm saying?
Yeah.
They're idiots. I'm sorry. Okay, so just remember the FAA questions and go with your answers. If I ask you a question, it might be something like, what are the two things that a debooster does? It lowers the pressure and increases the volume.
Okay.
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 Now here's a little thing. Okay. There's this little stem here with a spring and there's a ball on top. Okay. And I'm going to erase this, clear that part out. All right. Now, what this is for? Well, think this is going to the brake line, to the calipers. Could we have a small leak? Yes. If we had a small leak, eventually this piston would go all the way down and the brakes would fail. So this device here, okay, is designed so that if we lose some fluid, the piston comes down, right, compressing the spring, and the ball will be lifted off of its seat, so system pressure can come in to replenish the brake fluid to the caliper. Are we good there?
Yeah.
Okay. Now, this is what's known as a standard debooster, but they realized there's a problem with this standard debooster. Let's say this brake line totally ruptures and the pilot's applying the brakes. Guess what? This is going to go down and fluid is going to get pumped out of the aircraft, and it could be pumped out fast enough where then we lose all hydraulic fluid of the aircraft into the systems. Okay. Would that be a good thing?
No.
No. Okay. So they came up with what's known as a lockout debooster. Because to be honest, this replenishing was really done when you needed to bleed the brakes. Okay. When you bled these brakes, what would you do? Okay. You go to the caliper and you open up the bleed valve and you would have a pilot applying pressure to the brakes. You open up the bleed valve, fluid would release and pushing out air, hopefully. Eventually, this would go down far enough to allow system pressure to come in so that we could bleed that air. When we trapped it then, or closed off the bleed valve, this pressure would build back up and it would rise so that the valve is now off. Okay. By the way, this pin here is called a pintle.
Okay.
Okay. And you'll see it over here. Once again, there's the pintle. They still have the pintle. They still have the ball valve, right? But what they did was they added another valve on top of it attached to what they refer to as a reset handle. So now what has to happen? Let's say you as a mechanic need to bleed the brakes, for example, on the 727. We charge up the hydraulic system, okay? And we have somebody inside the cockpit. We say, apply the brakes. Well, down at the landing gear, we lift up on the reset handle or actuate the reset handle, which then lifts the slug to allow fluid to get to the ball. When we open the bleed valve, once again, the pintle will raise the ball off of its seat so system pressure can flow to allow us to bleed the air out of the system. Once we're done, we close the valve. The ball valve is seated, and then we close the reset handle, which blocks the inadvertent pumping of the fluid out of the system. And that's that.
Okay.
All right.
And that's connected to the entire hydraulic system in the whole plant. There's only one system?
All right. So going back in that, okay, I don't know what I did. What happened? I have no idea what happened there.
Can you still hear me?
Yes.
Okay.
Am I back sharing the picture?
Yes.
Wow, everything's like going black on me. It's like, I have no idea.
Yeah,
Wow.
I can see it.
Okay. But yeah, but all my background is all black. I don't have the,
Yeah, you're right. The background is black.
yeah. Okay, there's participants. Wow. No, my whole it's like my computer went to sleep on the background. Anyways, let me try again. All right, so when we're looking at this, here are the deboosters. Okay, so we have a debooster for each of our calipers. So when we come in Monday and we're doing the brakes and such, we can walk out to the 727 and I can show you the deboosters. I can show you the anti-skid control valves, the shuttle valves and such.
Okay.
But they're right on the landing gear. Are we good there?
Mm-hmm.
Okay, I have no idea what happened here. You still can hear me though.
Yes.
I'm trying to figure out. Oh, there we go. Okay, maybe that's. Wow. Okay, there we go. There we go. All right. I'm getting there. I'm getting there. New share. Okay. I'm back to where I don't know what happened, but we're back. All right. So. Okay, so we talked about the lockout style debooster that has a reset handle. And so to allow yourself to bleed the brakes, the reset handle has to be actuated so that we can bleed the brakes. Okay. This is what I was talking about with the emergency brake system on the instrument panel, right by the pilot, co-pilot. We have a pneumatic brake system. There is a breakaway wire here to prevent inadvertent actuation of the brake system. But then we just turn the handle that increases the brake pressure through the nitrogen going through the air oil transfer tube and stuff like that. All right, nothing special here. All right, it is going to be break time once again.
Okay.
Okay, and when we get back, we're going to talk about the brake inspection and servicing. So, we're page 35. We have about 5 more pages to go. Right? It shouldn't be too bad. So hopefully next half hour to 45 minutes, but we should be done one more out within the next hour. Are we good?
Okay. Yep.
All right. Okay, folks, I'm back.
Okay.
All right. All right, so what we're talking about now is the brake inspection and service and such. All right, so one of the things is making sure that the brake pads or brake pads, it's easy enough to say, brake linings are of within limits, that are not below wear limits and such. As said, here they're demonstrating the measuring of the adjusting pin, and understand that the adjustment pin, as it gets pulled in, it indicates wear. So we're making sure that it sticks out far enough or beyond its limit. Okay. If it gets below a certain distance, this is an indication that the brake linings have worn too much and need to be replaced. The other thing that I want to bring up on this is if we notice the hex nut here, safety wired, well, this is what puts tension on the grip collar so that the pin can only move inwards and not outwards. The important part about this is, let's say we have to replace the pads, right? Well, if anybody ever replaced your brake pads on your car, you know that you have to push the pistons back into the caliper so that the pads can go in and that there will be enough clearance. The same thing is true here. The only problem is the grip pin would not, or the grip collar would not let the pin move outward or back into the caliper. So what do we got to do? We got to cut the safety wire, release the jam nut there, so that the piston can be pushed back fully into the caliper. And then we have to properly torque that nut and re-safety wire. All right. All right. So another way is measuring the distance between the housing and the disc, but not very common. Now, I will let you know that on this one, I'm going to go a little bit more. Oh, why is this? I am having problems with it. Anyways, as you seen yesterday when you took the brakes off to remove the wheel from the axle, you could see the pads. So what do? We actually measure the pad itself. In this case, they're saying to use like a number 40 twist drill. And as long as the pad is thicker than the drill bit, or the thicker than, the distance of the minimum thickness of the pad, then they're still good. If not, the pad needs to be removed and replaced. I'm not really going to go too much into the removal and replacement because that is what we're going to be doing on Monday. All right. Also, what we're doing on Monday is bleeding of the brakes. All right. So basically, bleeding of the brakes is where we are making sure or removing all the air from the brake system. Why do we want to do this? Well, air, once again, is compressible because it's a gas, where liquids are non-compressible. When we have air in our brake system, when the pilot applies the brakes are going to feel spongy and we will not get full braking efficiency. So customer comes in and says, hey, I feel like my brakes are spongy, and you test them and you go, yes, I feel the same. So what do? We're going to remove the air from the brake lines, and this is known as bleeding. There are two general methods of bleeding the brakes. The one on the right is the way that a lot of people have heard about or have done, and that is actually known as the gravity method. This is where somebody is inside the vehicle or aircraft, and another person has a line connected to the bleeder valve of the caliper going into a small container. And what do? We tell the person, all right, pump up the brakes. And that's basically try to get them as hard as possible by working the pedal. And then the person will say, okay, holding And the person inside is to hold pressure on the brake and don't release the brake. Just keep on putting pressure down. Now, the bleeder, will then open the bleed valve, and with the person pushing on the brake pedal, will push fluid out through the caliper and into our container. We will then close the bleed valve and tell the person, okay, pump the brakes up again. And we repeat this until the brakes feel solid and no more sponginess. Okay. We can see it takes 2 people, but the problem in this system is a couple things. One, air wants to go up. It doesn't want to move down, so we're fighting it. 2, in many aircraft, the capacity of the reservoir can be rather small. And so if we got to bleed all this out, there's a possibility, if we're not careful in maintaining the reservoir full of fluid, we could actually introduce air into the brake system, thus having to start all over again. The way that we're going to bleed the brakes on Monday is through the pressure method. In the pressure method, we open up the reservoir so we can see the fluid or attach a hose. In this case, they were able to attach a hose. We can't really attach a hose. And then we're using a pressure pot filled with hydraulic fluid under pressure, and we connect that to the bleed valve of the caliper. We are then going to open up the caliper and open up the pressure pot to push fluid up and through the master cylinder and into the reservoir until the reservoir is full. If you think about it, this is doing 2 things that the gravity method has a problem with. 1, we're pushing the air in the direction that it actually wants to go, and that is up. Number 2, we're also filling the reservoir. So when we're done, we are done. There's no air in the system, and we have completely filled the reservoir. Good, good. Now, let's say the customer came in and, and was complaining about spongy brakes. We feel, and we go, yes, spongy brakes. So we do bleed the brakes. But in the process of bleeding the brakes, we're not getting any more air out, and the brakes still feel spongy. Does anybody know what could cause spongy brakes besides air?
Bad master cylinder.
Okay,
Low fluid.
what's wrong with the master cylinder?
There could be a leak internally.
Okay, I like that answer, but here's the thing. If the master cylinder, for example, going back to our independent master cylinder, right? If pretty much the only place that we're going to get an internal leak is through this O-ring. And if that happens, we're going to get what's called a creeping brake. Okay. And what that means is when you first put on the brake pedal, it feels hard, but as we maintain the pressure, it slowly goes down. Now, the book calls that a fading brake, but fading brakes to me is when the brakes are hot. This is what I know as creeping brakes. They're creeping down. Okay. So I like the answer. It is a good answer, but spongy brakes, and this is also, by the way, an FAA question, that's why. Fading or spongy brakes, if it isn't caused by air, generally is caused by a worn out flexible line, okay? And that the brake line going to the caliper, right, is damaged. And when you apply pressure to it, it swells up like a balloon, okay? And that would give you that spongy feel without any air in the system. So we would be looking for deteriorated hoses. We would look, sorry to say, it's not the easiest to be able to find, but it generally won't happen with rigid lines, but the flexible lines. So sometimes we might even have to like disconnect and block off certain lines to see if we still have it, and then swap it out and stuff like that to verify. All right, but worn flexible lines are the cost. All right. By the way, that is bleeding of the brakes. We're almost done, folks. We're almost done. The other thing is if we're doing it, we're looking for loose rivets, any type of cracking and stuff like that. Here, if we had a leak around the piston, this is generally done by the piston O-ring right here. Now, a lot of piston O-rings also have what's called a backup ring, especially if high pressure is going to be associated. This backup ring is usually like a Teflon piece. Looks like a Teflon washer, but it will have a concaveness to it. Backup rings, is always going to be on the opposite side of the pressure. So in this case, pressure is always going to be on this side. And the purpose of a backup ring is to prevent the O-ring from deforming. Okay. If the piston is double acting, meaning pressure could be on either side, then we use two backup rings, one on each side. Okay. This is really just a breakdown. This is of a floating disc system. The brake lining, kind of the important part on this is this. Unlike the other brake linings that are riveted to, say, a plate, the linings or pucks generally for a fixed caliper floating disc are not physically attached to the piston or any type of plates. They're actually held in by the disc distance. Okay, so they're kind of a pain in the butt because you have to kind of remove the wheel and slide the disc away or out of the way of the pads. And then you take the pads and you put them in, and then you try to slide the disc in between. And there won't be enough space for the pads to be or come out. Now, this can be rather difficult or a pain in the butt. And the thing that I want to warn you about is make sure you follow the manufacturer's instructions. I have seen, and the problem is that some people go, I can't get this pad to stay in place long enough for me to put the disc in between. Hey, I know what to do. I'm going to take a little bit of grease and put it onto the brake pad so it will stick to the piston. And yes, does it work? Yes, it does. But hopefully we can see a problem. You just put grease on the brakes. Now, initially the grease ain't there, but once the brakes evaporated, the brakes get hot, that grease is going to start moving around. It will get onto the discs, and now you have greased up your discs and pads, and that's a bad thing. Okay.
Terrible thing.
I've seen where people have used basically rubber cement to glue the pads onto the discs. Okay. One of the things that how these brakes are designed is that sometimes how the pad touches the piston specifically, there's sometimes a piece of cork as an insulator, because the pad's going to get hot. If that pad comes in direct contact with the piston, it can actually create a thermal conductor so that the brake fluid gets hot and boils, which is not good, because if it boils, it turns and it can actually coat what's called coke up. It's solidify, and which then can block passages and stuff like that. So always follow the manufacturer's recommendations. Here is kind of the brakes that we looked at yesterday, right? We have a pressure plate, the back plate, and in this case, the brake linings are actually riveted to the pressure and the back plate. Now, this one's interesting because it shows this shim, okay? What's interesting is that on some aircraft, if the brake disc is new, because also they don't talk about it very much here, but one of the things that we also have to inspect is the brake disc and the thickness of the disc. And there will be limits to how thin the disc can be to be serviceable, okay? Well, let's say we replace a worn out disc with worn out pads, okay? All of the wear surfaces are worn beyond limits. So we replace with a brand new disc and brand new pads. What's crazy is in that setup on some aircraft, there's a shim that has to be installed for it to be able to go together, because the disc with new pads can be so thick that there's not enough space that if you do not use the shim, the brakes will drag. Now, what do? Well, we use the shim, and then after a while, after the brake pads have worn or the disc has worn, okay, then we're going to find that there's too much travel in the brake pedal, and thus the shim has to be removed. By removing the shim, this brings everything back closer together and it's operational. The funny thing is, what does the mechanic do with the shim? They're supposed to give it back to the owner operator and say, hey, hold on to this, because in the future, if you need new discs and pads, you're going to need this shim. And rather than the facility having to charge you for new shims. Okay. I'm not really going to talk about this device because we will be seeing it on Monday. And oh, guess what? That is the end of the lecture.
Okay.
All right, so I am just going to say for you that today's lecture is over. I will be ending the meeting. I did send out an email yesterday that, yes, we have the lecture today. Monday, we are in the shop, okay? The projects that we're doing is we're doing the brakes, both, the inspection of the brakes and bleeding of the brakes and the master cylinders. And we will also be servicing oleo struts.
What
Okay.
tools do I need to bring?
Yes, bring tools.
Okay.
There's no special ones, just what you normally should bring.
Okay.
All right. But that's what we're doing on Monday. On Monday, then I will discuss our options for Tuesday. But, we do still need to lecture over tires, and we also have a quiz that's coming up. So
Okay.
we'll discuss that on Monday.
Okay.
All right. Any
Cool.
questions before I get away from you?
I'm good. I don't know if anyone else has a question.
Anybody else have any questions?
I do not.
Okay, everybody good then? Remember, Monday, we're back into the shop, all right?
Perfect.
Somebody besides Kayla say, okay,
No problem.
all right, very good. Folks, see you Monday, 7:30. All
All
right,
right, Monday.
bye.
Okay, bye.